Good day, viewers. You welcome back to my YouTube channel. This is Chem Easy, and this is the qualitative analysis of what you should be expecting. You should be expecting questions like this. But before we go over to the practical and proper, please do well to subscribe to my YouTube channel. A lot has been put into place to ensure you understand this very well, and the only good you can do for us is to subscribe. It won't take you anything. If you've downloaded this video, you can go to my YouTube page and just click the subscribe button. Please, that's the only way you can help us out. Thank you very much for complying to that. So this is a sample question, and it says C is a mixture of two salts. So you'll be given two salts, a mixture of two salts, and that salt is lead nitrate and sodium carbonate. Now take note of this. All nitrate salt are soluble in water. All nitrate salt are soluble in water, and all carbonate salts, they are insoluble except carbonate salt of sodium carbonate, potassium carbonate, and ammonium carbonate. All right, these three carbonates are soluble in water. Aside this one, all other carbonate salts are insoluble in water. So when you mix these two salts together in an aqueous solution, you will have lead. Okay, you have lead carbonate and sodium nitrate. Lead carbonate and sodium nitrate. All right, now take note of this. Initially, I said all carbonate are insoluble except these ones. Now, you should note that lead carbonate formed from mixing these two salts is insoluble. Okay, so you have a white precipitate. A white precipitate when you mix these two together, a white precipitate of lead carbonate, which is your residue. And also you will have a filtrate. Take note, I told you all nitrate is soluble in water, so you should expect sodium nitrate to be soluble in water, and this is your filtrate, and it is soluble in water. So C, when you dissolve it in water, will be partially soluble in water to give you lead carbonate, which is your residue, and sodium nitrate. So now let's go over to the question proper. Now the question says C is a mixture of two salts. Carry out the following exercise on C. Record your observation and identify any gases involved. Alright, put all of C in a test tube and add about 10 ml of distilled water. So you can go through it, and then here is the table for the practical. Okay, so this is where I want to focus more on. Now the first one here says C plus water, stir and filter. All right, so when you add water to C, C will partially dissolve in water to give a colorless filtrate. Take note of this. The filtrate, which is sodium nitrate, is colorless. All right, and then it will also give you a white residue, which is your precipitate, and that white residue is lead carbonate. So the inference here will say C is a mixture of two salts. So we add our lead salt and our sodium carbonate salt, and they will mix together. Pour to your beaker, and then we'll add distilled water and stir very well. After this, you go further to set your filtration apparatus. This is your filter paper. You fold it into 2 and into 4, and the 1/4 of it, you divide it into 2 and place it firmly inside your funnel. So go further to add the mixture of the salt through the filter. You observe that the filtrate goes through the filter paper while the white residue remains on top of the filter paper. The filtrate is colorless the residue is white in color. So here's our filtrate. You can see that it is colorless, and then we'll turn it into probably a boiling tube. Also, there is a white precipitate, the residue. So we turn it into our boiling tube gradually. Now, the residue plus heat plus lime water. If you heat the residue which is lead carbonate, if you heat it, you will have an effervescence of a colorless and odorless gas that turns most blue litmus paper red and lime water milky. Alright, so the gas is acidic and the gas is carbon dioxide gas from carbonate gas. In case you want more explanation on this, here's a brief explanation of that. When you eat lead carbonate, you will have lead oxide plus carbon dioxide gas. This gas will be given off. Okay, now when this gas is allowed to pass through lime water is calcium hydroxide. It is called lime water. All right, you will have calcium carbonate plus water. All right, so this calcium carbonate is the white precipitate. Okay, that milkish kind of precipitate you see in the lime water is as a result of the formation of calcium carbonate. So that's just a quick one. All right, so here's the video and the explanation for that. So you have to heat the residue strongly to give off the carbon dioxide gas. So when you heat the residue, the lead carbonate decomposes to give you carbon dioxide gas, which is passed through the lime water. And you observe the lime water start changing to a milkish color, as you can rightly see in the video. All right, the next one is the residue plus HNO3. You observe that the residue dissolves to give a colorless solution, and the inference is the residue is soluble in HNO3. Here's the video demonstration. All right, so we add the residue to a fresh boiling tube, and then we add nitric acid. You observe that it dissolves the precipitate to give a clear solution. Residue plus sodium hydroxide in drops. Sodium hydroxide in drops gives you a white chalky precipitate or a white non-gelatinous precipitate, and that indicates the presence of calcium and lead. It is only calcium and lead that gives a non-gelatinous or a chalky precipitate with sodium hydroxide. Then in excess, these are you differentiate between calcium and lead. In excess, lead will dissolve in excess of sodium hydroxide, but calcium ion will not dissolve. It is insoluble in excess of it. All right, here's the demonstration. So you divide it into 3 test tube, 2, 3, and then to the first one you add sodium hydroxide in drops. You observe a white non-gelatinous precipitate, a white chalky precipitate which is soluble in excess. In excess, the precipitate dissolves to give a clear solution, as you can see. So the residue plus ammonia in drops, it also gives a white precipitate. which is lead present, and in SS it is insoluble in SS, which confirms the presence of lead. So here's it. Adding ammonia in drops gives you a white precipitate. In SS it is insoluble, as you can see from the video. Now the white precipitate, the residue form, which is the lead carbonate plus HCl, it gives you also a white chalky precipitate. Then on heating, the precipitate dissolves on warming and reappears on cooling. And the last portion with HCl, it also gives a white precipitate, which on warming dissolves. Then if you allow it to cool, the precipitate reappears. And take note, this first part is on the residue. Okay, so these are likely exercises you'll be asked to carry on the residue. Then the last part of it is on the filtrate, which I doubt if they will ask you to do this because of the usage of concentrated sulfuric acid. Students might not be careful enough and to handle this, so they might not ask you to do this, but in case they ask you to do this, this is just what you should be expecting. So the filtrate plus dilute H2SO4 plus the freshly prepared iron 2 sulfate, or which is the one you used in your quantitative analysis. All right, and then when you add it, you tilt the test tube in a slant position, and then you add concentrated sulfuric acid in drops. If you do that, you will have a brown ring that will be formed just at the junction of the acid below and the solution above. If this happens, it confirms, or it tells you that nitrate anion is present in that solution. So that's it's called a brown test for nitrate anion. All right, so here's the practical demonstration for this step. All right, so these are our filtrate. We'll add our filtrate into the test tube, and then we'll add the freshly prepared iron 2 sulfate to it, and then we tilt the test tube in a slant position and add the sulfuric acid, concentrated sulfuric acid, take note of that, in drops. So when you do this, you need to be very careful with this. All right, you add it in drop, and then you allow it some time for the brown ring to form. All right, so mere looking at it, you will see the brown ring just at the junction between the acid below and the solution above. Let me give you a clear view of that. You can see the brown ring just below the acid and the solution above. So this confirms the presence of nitrate. So if I should straighten this very well, carefully, hope you can, yes, now you can see it very well. So this is how you test for nitrate ion in a solution. Please, if this video has helped you, do well to subscribe. Thank you very much.